Okay, let's dive right into this. Welcome to The Explainer. Today, we're embarking on a completely invisible, frankly fascinating journey into the everyday magic hiding right there in our standard hand washing routines. I mean, we do it multiple times a day without a second thought? But the actual science happening right at your fingertips is nothing short of incredible. So, let's unravel the hidden molecular bridges that keep our world clean. It all starts with a super relatable problem. Every single day, our skin, our clothes, everything we touch accumulates dirt, sweat, and crucially, oil-based grease. Now, if you've ever tried to rinse a greasy frying pan with just plain water, you know exactly what happens, right? Absolutely nothing. The water just beads up and rolls right off. Water alone completely fails to clean it because, at a fundamental chemical level, water and oil simply do not mix. They are literally sworn enemies. And the reason for that intense rivalry comes down to this core chemical conflict. It's basically the golden rule of chemistry. Like dissolves like. So oil dissolves in oil, and water dissolves polar substances. Oil is nonpolar, water is polar. Because they're completely unalike, they refuse to interact, which creates this stubborn, microscopic stalemate right there on your skin or on your favorite shirt. To break that stalemate, we need a mediator. Which brings us to part one, meet the soap molecule, the bridge between two worlds. Because to break this stalemate, we are going to need a hero. Enter our invisible savior. Chemically speaking, soap is a sodium or potassium salt of long-chain fatty acids, but its entire purpose in life is to connect two worlds that otherwise flat out refuse to speak to one another. To understand its superpower, you've got to look at its two completely distinct, highly contradictory ends. On one side, you have the hydrophilic head. Hydro means water, philic means loving. This end is polar, so it absolutely loves water and dissolves right into it. But on the exact opposite side of the molecule, you have a long, non-polar hydrocarbon chain called the hydrophobic tail. Phobic meaning fearing or hating. It completely hates water, but it's incredibly attracted to oil and grease. Now, what's really interesting about this slide is the scientific term for this split personality, which is amphiphilic. Because soap is amphiphilic, meaning it possesses both water-loving and water-hating properties at the exact same time, it's uniquely equipped to connect those incompatible worlds we talked about earlier. It literally holds onto water with one hand and grabs onto oil with the other. This invisible action brings to mind a fantastic mental image. Just close your eyes for a second and imagine soap molecules as an army of tiny creatures. You plunge your soapy hands into the sink, and boom, millions of these tiny creatures immediately deploy. They rush at the grime, grabbing the oily dirt with their hydrophobic tails, while their hydrophilic heads reach out and desperately hold on to the surrounding water molecules. It is a highly coordinated capture mission. And that capture mission culminates in the climax of our story, the formation of a micelle. When these soap creatures are added to water and strategically surround the enemy grease, they naturally organize themselves into this cool spherical structure called a micelle. All those oil-loving hydrophobic tails face inward, burrowing deep into the grease, while the water-loving hydrophilic heads face outward, forming this protective shield that perfectly interacts with the surrounding water. The grease is now completely trapped inside a tiny molecular cage. Okay, let's pick up the pace and walk through the exact 5-step microscopic attack plan as it happens. Step 1 is wetting. Water spreads over the surface. Step 2 is absorption, where our soap molecules attach to the grease. Step 3 is the big magic word, emulsification. This is where the grease is actively broken down into tiny droplets inside those micelles. Step 4, suspension. The trapped dirt just stays floating there in the water. And finally, step 5, rinsing. Because the outside of the micelle loves water, the whole package, grease included, is effortlessly washed straight down the drain. It's a pretty serious superpower, but where does this natural hero actually come from? Well, the secret lies in a process called saponification. This is the chemical reaction that gives birth to soap. By taking natural fats or oils and combining them with an alkali, like sodium hydroxide, the reaction yields soap and glycerol. And actually, fun fact here, ancient Babylonians mastered this basic process over 4,000 years ago. They literally combined animal fats with wood ash just to stay clean. Moving on to part 2, the hard water problem, or as I like to call it, our hero's kryptonite. Because our hero isn't invincible, and we've got an arch-villain you've probably battled in your very own shower. See, if you live in an area with hard water, the stuff coming out of your tap isn't just H2O. It contains heavy concentrations of calcium and magnesium ions. When our soap molecules encounter these specific ions, disaster strikes. Instead of forming those nice cleansing micelles, the soap chemically reacts with the calcium and magnesium to form an entirely new insoluble substance. It completely neutralizes our soap hero, prevents any lather, and instead just leaves behind a gross, useless layer of scum. Which brings us to part 3, detergents to the rescue, the synthetic sidekick. Clearly, science couldn't just let the hard water villain win, right? Synthetic detergents were explicitly designed as a modern chemical upgrade to bypass the hard water problem altogether. These detergents are incredibly versatile, ensuring we can clean our clothes and bodies no matter what ions are floating around in the plumbing. You've got anionic detergents, which are your heavy-duty washing powders, cationic detergents, which are excellent disinfectants, and non-ionic detergents, which are super mild, think baby shampoos. But their true superpower, when they hit hard water ions, they don't form scum, they form soluble compounds. That means the attack plan, the emulsification, the cleaning, it all continues uninterrupted, no matter the water type. And this brilliantly illustrates the practical pros and cons of our natural hero versus its synthetic sidekick. Soap is derived from natural fats and is generally cheaper, but it completely fails in hard water. Detergents, conversely, are derived from synthetic chemicals and are often a bit more expensive, but they win that battle against hard water every single time. Now, we do have to mention, this rivalry has real-world environmental impacts that we can't ignore. Because soap is made from natural fats, it's completely biodegradable and eco-friendly. It returns to nature easily. Detergents, historically at least, have had a darker side. Some synthetic detergents have been non-biodegradable, which led to water pollution and these massive, unnatural foam formations in rivers. But the good news is that modern detergents are actively being improved and reformulated to be much, much more eco-safe. So let's bring this all back to your everyday life. Whether you're taking a bath, tossing a load of clothes into the wash, or mopping the kitchen floors, you aren't just doing chores. Every single time you wash your hands, you are witnessing applied chemistry in action. You're literally deploying amphiphilic molecules to form micelles and execute molecular capture missions through emulsification. It really changes how you look at a simple bar of soap, doesn't it? And it leaves us with this provocative thought. If a simple drop of soap commands a literal, invisible army of chemical bridges, what other incredible molecular miracles are hiding quietly in your daily routine? Next time you're staring at your perfectly clean hands, I really hope you remember the microscopic battle that just took place to make them that way. Thanks for joining me on this explainer, and keep questioning the science hidden all around you.